approaches 0 of sine of 4x over sine of 6x. All right, so when I look at this, the very first thing that I want to do is that I want to see what happens if I were to plug in x equal to 0 into our function. My thought bubble here, we're going to be over to some side work. This is done on my bar napkin so I can crumple it up and throw it away. I've got sine of 4 times 0 over the sine of 6 times 0. Now sine of 0 is 0, and as is sine of 0 on the bottom. So we end up with 0 over 0, and this tells us that, number one, because I have that 0 in the denominator, I am not allowed to just willy-nilly plug in this x equal to 0 into the top and the bottom and get a final answer. It tells us I'm going to have to do some more work. Now, because I have trig functions in here, there's not a lot of simplifying I can do. So the next thing I want to think about is, well, what do I know about trig functions? And I know that the limit as x goes to 0 of sine x over x is equal to 1. Now, a second thing that we might also know, or that we could deduce from this, is that if you have a ratio that gives you a value of 1, if you flip that ratio upside down, you still get a value of 1. So, another observation is that it is also true that the limit as x approaches 0 of x over sine x is equal to 1. Okay, because the reciprocal of 1 is 1, so if we take a reciprocal, okay, so these are the pieces of knowledge that we have. All right, so Don, you asked about 44. What kind of thoughts did you have on 44?
Well, I was going to try to multiply something the factor out to get sine x over x, but then
Okay, so you tried a couple things trying to get sine x over x, but didn't quite work out for you. But you're along the right track to say, I want to make it look somehow in this particular form. All right, Ben, are you thinking, or do you have an idea?
I have an idea, I guess.
Okay, what's your idea?
Could you multiply by, or sine of 4x over 1 times 1 over sine of 6x?
So rewrite this?
Yeah.
Okay, so maybe let's rewrite this expression so that we have sine of 4x over 1 times 1 over sine of 6x.
Is that allowed?
Seems totally legitimate to me that this expression is exactly the same algebraically as the one right before it.
Okay.
Okay? Okay. So now what I see, at least with the sine of 4x, is that I see a sine of something, which is kind of like this first expression here. Now, what I need to make it match up is I need an x in the denominator. So maybe I would throw in an x in my denominator. Now, of course, I can't just willy-nilly throw an x into the problem any old place I feel like throwing it in. If I throw an x into the denominator, I've got to also throw it in the numerator. And take a look, if I throw the x in the denominator here, well, this sine of 6x needs an x to go along with it. So maybe I'll put the numerator x above the sine of 6x. So what I've done is I've multiplied this entire expression by x over x, which means I've really multiplied by 1, and so it's legitimately the same value. Okay. So that right there was a form of mathematical trickery. Absolutely valid trickery, but mathematical trickery. Now, our values are still not the same. Notice that over here, the limit as x goes to 0 of sine x over x equals 1. The input into the sine function matches exactly the value on the bottom. So our value inside of our sine function, our input is 4x. So if I want a 4x on the bottom, well, I need to multiply this x by 4. And if I do so on the bottom, I've got to do so on the top. And the same with the sine of 6x. I want a 6x in the numerator, and so if I multiply the numerator by 6, I'd better also multiply the denominator by 6. All right, so taking a look at what we've done here, we've multiplied the top and the bottom by 4, top and the bottom by x, and the top and the bottom by 6. So we've done a lot of sort of massaging of this problem and getting our hands dirty, but we have not changed the value of this expression. All right, so from here, everything seems to be going pretty well. I've got this extra 4 there, and I've got this extra 6 in the denominator, so I'm going to rewrite this one more way. Limit as x goes to 0 of 4 over 6 times sine of 4x over 4x times 6x over sine of 6x. And so now I'm taking the limit of this entire expression here and thinking about my limit laws. If I distribute this limit symbol, I can distribute to each term in the product as long as my limit exists for each term. So for the first term, I have the limit of a constant, which would give us 4/6. My limit as x goes to 0 of my second term, that's going to be 1. And for my third term, well, that's our reciprocal, so that's our observation that the limit as x goes to 0 of x over sine x also equals 1. And so for our last value up, we also have a 1. And so in the end, our final limit is 4/6.
Or 2/3.
Or 2/3, thank you.